In this fourth video for your calculus revision, we're given this diagram here and we're told as x increases, so does BE. So we have x increasing in this direction as the arrow shows, so BE is obviously going to increase as well. And x is increasing at a rate of 4 meters per second, so the x dt is equal to 4. Find the rate at which BE is increasing. Well, we can get BE in terms of 7 and x. BE squared using Pythagoras is equal to 7 squared plus x squared. So BE is equal to the square root of the other side, square root of 49 plus x squared. That should help start the question. We are asked, so find the rate at which BE is increasing, and at the instance when the triangle is isosceles. Okay, so therefore give your answer correct to 1 decimal place. Okay, let's call BE y. So we're looking for the rate at which this increases. We're looking for dy dt. We already have the x dt given, so we'd have to multiply that by to get dy on top. dy is there. We want to get rid of the x, so dy dx. So we have y in terms of x. We have y BE is equal to, I'll write it to the power of a half, 49 plus x squared to the power of a half. So this is how we're going to get dy dx. dy dx is going to be a half times the square root of, a half times, get rid of the square root, 49 plus x squared to the power of, reduce the power by 1 minus a half, and then we're going to have to multiply by differentiated bracket, which is just 2x. So these twos will cancel straight away, and we're left with x over, bring it down and make it positive, 49 plus x squared to the power of a half, or the square root of. So this is dy dx. And we're filling in dy dx, so we have the x dt, so we're looking for dy dt. So dy dt therefore becomes dx dt, which was 4, times dy dx, which is x over the square root of 49 plus x squared. And we're told that the triangle is isosceles. What was the other side? 7. So therefore x has to be 7 for it to be isosceles. So that's going to be 4 times 7 on top, and the square root of 49 plus 49, the square root of 98 on the bottom. And that does simplify, but we just type that into a calculator and it gives me 2.8 meters a second. Correct to 1 decimal place, I think. Yeah, correct to 1 decimal place. So the next question is this one here, which I'll bring the second part of up now. We're asked to find the range of values for x for which this goes negative. So just differentiate and solve. I think it's another quadratic formula one. So f prime x is 6x squared minus 42x plus 40. When is f prime x negative? This will have to be less than 0. So try to factorize it a couple of times. I don't think it's factorizable, because when I did the quadratic formula, I get two values. I get x is equal to, so I use the quadratic formula here. Quadratic formula, the two values are 1.137, 2 decimals, so 1.14, and 5.862, so 5.86. So x is going to be between these two values, 5.86 and 1.14. Nice easy question there for this one. In this question we were asked to draw the derivative. So we have the cubic function, and it's between 0 and 4. The information we're given is the max value of p prime x in the domain is 1. So the max value is 1, so it's going to go up to a max of 1. And p prime 0 is minus 3. Well, that's going to be there. And the roots, the midpoint of the roots is the point of inflection, and the roots of the derivative will be at the maximum point. So 1 and 3, it looks like 1 and 3, and the max value of the derivative is 1, so the midpoint of 1 and 3 is 2, so 2, 1. So these are the points that they were looking at here, and then obviously if it's symmetrical, we'd have that point there too. So the derivative looks something along these lines. Please try and draw it a bit better than I can. This question, we have a rectangle expanding an area. Its width is x. So let's go x, draw the rectangle. So the width is x and the length is always 4 times its width, so 4x. So you get the area straight away. The area is 4x squared. Find the rate of change, so we're looking for the ADX. And what are we told? When the area is 225, so the area has to be equal to 225. So x squared will be 225 over 4. We can get the square root of both of those. X is equal to square root of 225 is 15, and the square root of 4 is 2. So we're looking for the ADX when x is 7.5. Okay, so the ADX is going to be equal to differentiating 4x squared. We're just going to get 8x. And if x is 7.5, we get 8 by 7.5, which is equal to 60 centimeters squared every centimeter. Nice easy question there. Next one, a student is asked to memorize a long list of digits and write down the list sometime later. For the proportion of the digits recall correctly can be modeled by this function here. P of t is equal to 0.82 minus 0.12 by the natural log of t plus 1. So it looks a little bit awkward. This is between 0 and 12. And we are asked to find p prime 1. So we need to differentiate this guy. So we're going to get minus 0.12. What does ln x goes to 1 over x. So ln t plus 1 goes to 1 over t plus 1. So the constant in front is minus 0.12 by 1 over t plus 1. And if t is equal to 1, we get minus 0.12 times 1 over 2, which is minus 0.06. P prime t is always negative, so obviously as time goes on, you're going to remember less and less, or as the list of digits gets longer and longer. And I think that's what they're looking for here in this part of the question, just some sort of explanation as you're asked to memorize a longer list of digits, the amount that you remember will become less and less, therefore the derivative is negative, or the proportion goes down as t goes up, something along those lines would work here. And then the last part is use calculus to show that the graph has no inflection point, so we have to have p prime prime t cannot be equal to 0. Okay, so we have p prime t already. P prime t is equal to, we got minus 0.12 over t plus 1. If we have that to the power of 1, that would be equal to minus 0.12 by t plus 1 to the minus 1. So if we get the derivative of this, p prime prime t, going to get minus 1 by 0.12 is 0.12 minus by minus, and we're going to get times t plus 1 to the minus 2, which is equal to 0.12 over t plus 1 squared. So as t plus 1 squared is positive, therefore p prime prime t cannot be equal to 0. Therefore, no inflection points. So quite a bit in the first 4 revision videos. I'll add a few more, and then if you're not experts on calculus by the time you get to June, you have nobody to blame but yourself.